Hey guys, okay, here's our graphing calculator practice that we started in class today. So we're going to finish this, and then also you're going to try the problems on the back, hopefully, if you understand everything. So first of all, so here's a graphing calculator. So you have some sort of graphing calculator or graphing calculator app. Right now, these are on sale at Staples, I think, and also Amazon. So if you're thinking about getting a graphing calculator, just buy it now because they're on sale. I think these are, instead of like $150, they're like $120. But if you want something cheaper, get it on eBay or get a TI-83. This one, the only reason I would recommend this is because they're faster and they're smaller. They're like lighter and faster. They graph faster, okay? So I turned it on, and then I'm going to show you how to clear it. So the first thing we're going to do, no matter what, is clear the calculator. I'm always going to ask you to do this, and I want to ask for the screen a lot, like especially in class, you know, before or after a test or whatever. So to clear it, you press second plus 712. So second plus 712. So again, it was second plus 712. And if you read it, you'll see why that works, okay? But it's always going to be like that if you have a TI-83 or TI-84. All right, so RAM cleared, that means the memory is cleared. I'm going to go to y equals. I'm going to go ahead and put our equation in. So remember, we always have to solve for y first. So we're going to solve for y, and then I'm going to do, I can do 0.3 or I can just do 0.3, okay? So I'm going to go ahead and do x to the power of 3, and then minus 0.9 x squared, and then plus 4. Go ahead and graph that. And my normal graph looks like that. That's our standard view. So my standard view, I did the tick marks. You can see I did my little tick marks. And then I graphed it. It looks something like that. Try to be as neat as possible, okay? This is standard view. So if I go to zoom, I can see Z standard. That's my standard zoom view. Okay, so this graph is already in standard view. But you do see how these tick marks are like more squished on the y-axis. So really, this should be like stretched out this way, like longer, or the x should be like pushed in so that we see a better image. Because right now, our little pixels, like each little pixel is a rectangle. We want squares. So what do? We go to zoom square, and that'll give us little square pixels. So zoom 5, it's also called Z square. So I'm going to press 5. And then that's how I drew this one. And you can see this one is a little bit skinnier than this one. Okay, so when I ask you questions like to draw them or whatever, we can see why this is a little skinnier, because really everything got smushed in this way. So I took this, smushed it in this way, and then I got this picture. Okay, do you want to know what that looks like in the window? Here, I'll show you in the window. So in the window, oh, that's what happens. Really, the top and bottom were 10 by 10, and the left and right for the x-axes are now negative 16 and positive 16. And that makes everything so that it's not distorted. Okay? So we're going to go back to standard view. So zoom 6. And then we want to change our scale of the window. So right now it's going by 1s. We want to change that to 2. So I'm going to go ahead and go to window. And I'm going to go to my x scale and change it to 2. And then my y scale, I'm going to change it to 2. And then graph. And does this graph look any different technically from the original graph? No, it looks exactly the same. The only difference is there's less tick marks, because these tick marks are every 2 units. So that's why it's really important to put a little 2 here. If you're the one graphing and giving me an answer or whatever, you have to put a little 2 here or a little 1 here so that I know, is it going by 1s, is it going by 2s, is it going by 5s, is it going by 10s? So really, these graphs are the same, but the tick marks make it seem different. It makes it seem like it's zoomed in, but it's not, okay? So be real careful. Okay, so maybe I want to change it to, I'm going to go back to standard. I know, I keep going back. And then I want to change my window. So I want to see, instead from negative 10 to 10. Well, this is negative 16 to 16. Instead of that, I want to go from negative 6 to 2. So I want to see this little itty bit of my window. I don't know why, but I just want to see that part. So then you just go to window, and then you go ahead and change it. So make sure a negative, you're using this negative right here. So it's down here. This is minus, this is negative. So make sure you use negative 6 to 2. And then we change that back to 1, and then negative 3 to 3. I'm going to go ahead and graph it, see what that looks like. And that is how I graphed this one. So you can see, like, I really have all the tick marks too, right? So 1, 2, 3's up here, 1, 2, negative 3's down here, 2's on the right, 6 is on the very left. So I'm really trying to copy as much as I can what I see in that picture, okay? What do you do to zoom in and zoom out? All right, let's zoom out. How do you zoom out again? You go to zoom. You pick the one that says zoom out. You can click 3, or you can scroll down to 3 and click enter. But you see that nothing has changed. So when you zoom in or zoom out, this is a, well, sorry. This was, zoom in was like a 2, right? It was pressing 2, this was pressing 3. But what you actually have to do to make it zoom in or out is you have to press enter. And then it actually, so make sure that you write that too. And then it actually will do the zooming, okay? If you want to zoom out more, you just zoom out more, you press enter. You don't have to press zoom. You just press enter one more time. It's going to zoom out even more. And then if you want to see what window that is, you go to window, oops, and then it's showing, oh, okay, wow, it's like, you know, so zoomed out. Look at that. Okay, so I'm going to go back to standard view. And then these numbers, remember, these came from the chart, which is called a T-chart, which is called a table. T stands for table, okay? So table is up here. Second graph takes me to the table. This is fine. I can fill it in from here. I can scroll up and fill in what I need, okay? But here's a giant tip, and we really want this for if I had written here 200, here's what you'd want to do. You want to go to your window. Actually, you want to go to your table set. So I want these numbers to be different. So I'm going to go to, instead of table, my table set. So second window. Let's say I want to see what happens at 200. I just put 200. And then let's say I want to go by, I don't know, 5s. So I go by 5s. And then I go to table. And now I can see, ooh, 200 right away is 2.3. Actually, it's like 2.3, da, da, da. This is like very close to 0. So I just made this up, but this is actually very close to 0, just so you know. When it says E something, it's like very, very close to 0. It's very weird. Okay, so if I wanted to, let's say, start at -5, then I could, there we go. Okay, actually 200, wait, 200 wouldn't be 0. Oh, I know, sorry. The e to the something power, when we put in 200, I'll explain what it's doing. Because I don't want you to think this is 0. Okay, so what this is really saying is this is 3.6 times 10 to the 6th power. Something like that, okay? So this is telling you it's really like 3, I don't know, 3 million, 36 million, something like that, okay? So this is a huge number, and it just gets bigger and bigger. So this is like times 10 to the 6th power. That's what it means. Okay, I forgot. Okay, so the actual important stuff. So here's the actual important stuff. I'm going to go back to here so we can see. Okay, we're still talking about the same one, and now we're talking about X-intercepts. So X-intercepts also are called roots, solutions, or zeros. So you have to know that they're totally interchangeable. So any one of these words mean X-intercepts. So to find an X-intercept, usually we do it algebraically. How would we do it algebraically? We would take this equation, we would set it equal to 0, because when y is 0, you get x-intercepts, right? So we set this equal to 0, and then we try to solve. Okay, the problem would be that we don't know how to solve that. It's not factorable, like we can't do anything with that. So instead of us solving it, we're going to use our graphing calculator, and the calculator will literally calculate the zeros for us. It's amazing. So our graph, zoom 6, our graph, we can see there is an x-intercept right here. That's what we want to find. Okay. Oh, by the way, it said, what's the y-intercept? Make sure you don't say 4. That's not an answer. Make sure you don't say y equals 4, because y equals 4 is literally a horizontal line at y equals 4. The y-intercept and x-intercepts are points. Okay, make sure you write points. All right, back to this. So how you find an x-intercept, how you find that is you calculate. Where's calculate? It's up here where it says calc. So second trace, and you're calculating zeros, right? Because zeros are the same as x-intercepts. So now you press 2, or you scroll down to 2. Okay, you don't want that one, right? You want to find, I'm using the left and right buttons. Never, never, never use up and down, only left and right. So I want to find this right here, basically, but I want to find it exactly. So your calculator asks, what is your left boundary? My left boundary of what I want you to calculate, Mr. Calculator, is right here. So I want to be to the left of this intersection of the graph and the x-axis. So over here would be to the left. I press enter. Now I need a right boundary. I'm going to go to the right of the x-intercept. I'm going to press enter. And then the calculator says, do you want me to guess? Yes, I do want you to guess. So here you go. All right. So my 0, or my solution, or my x-intercept is negative 1.686. We're going to round to the nearest fourth digit. So negative 1.6867, comma 0. So that is my x-intercept. As close as possible, says my calculator, and I didn't have to do any hand calculating. Love it. Okay. Look back at that if you need help with that. I'm going to move on to the next part. So that is when you're calculating x-intercepts. The next part's a little bit different. The next part, I have 2 different equations. I want to find the other solutions. When you find solutions of 2 equations, you're actually finding where they cross, right? So that's different. This solution is the x-intercept. This solution is where they intersect, like that, okay? So I'm going to go to my y equals. I'm going to go ahead and clear that. And then I have my first x minus 1. I have my second equation, 2x plus 2. I'm going to go ahead and graph that. If it's not already in standard mode, make it in standard. Okay, I can see this is the intersection. So if this is my intersection, I want the calculator to find that. I don't want to use substitution. I don't want to use eliminations. I mean, I could, but when they're decimals, that's a pain in the butt, okay? So instead, I want the calculator to find it for me. How do you do that? Instead of calculating a 0, you're calculating the intersection. So calculate would be second trace, and then number 5, intersect. So you press 5. And I want to find this part right here. So again, don't press up and down. You go left, and you want to find the left of this intersection. It looks like it's about here, so I'm going to definitely go to the left of that. Press enter. I'm going to go to the right. Press enter. And then enter one more time. My intersection is -3, -4. And I wrote here, and find a good window. This was already an excellent window. I can see the intersection right here. But what if the intersection was like way down here? Like I knew it's going to intersect. I can see a line here and here, but I can't see down here. What do? You change your window. So if I want to see more negative, I would change that to maybe like a -20. And then I would change this to a -20. If I don't want to see any positives because I know it doesn't matter, then I can change those to 0. Let's look at what that looks like. So if I graph this, Oh, I see only quadrant 3. That's what I want to see. Is that really helpful to us? Well, we already found it. But, you know, if I wanted to see lower, that's what I would do. I would change my window. Okay? All right. So what you're going to do is you're going to flip your paper, and then on the back, you have homework 1.4b. You're going to do your best to try these. So it kind of leads you through the same kind of thing that we did on this side, except the first 2 questions, you're going to go ahead and, I think this one is x cubed, and then I'm just giving you a little warning. I remember that there are going to be 3 x-intercepts, okay? For this one, I remember there's 3 of them. So definitely you should have 3 answers. You're going to do that 3 times where you calculate the 0, and then you calculate another 0, and then you calculate another 0, okay? I'm telling you, there's 3 of them. For this one, there's 2 of each. There's going to be 2 y-intercepts, and there's going to be 2 x-intercepts. So I'm telling you right now, this one has 1 and then 3. This one has 2 and then 2, okay? So you're going to try this. You're going to set it y equals, put it into your calculator, all that stuff. And then you're also going to do these. These are like this one that we did, the last one where you're calculating the intersection. So also try these. You got to get it into y equals. And then I'm telling you right now, this has 1 intersection. So you're going to write that 1 intersection once you find all that stuff. This one, I'm telling you right now, there are 2 intersections. There's one that you're going to see on the screen itself in standard view, and then there's going to be another one that seems like it's off the screen, so you have to find it by doing this window. You have to change your window so you can find the other intersection. It's going to be somewhere up here, I think. And then you're going to go ahead and find both of them, okay? So give that a try, and then we'll get together tomorrow, and then you can ask questions, and I'll show you all the answers. All right? Good luck, good luck.